These bales contain the raw history of our consumption.
Released from compression, the sorting process begins. Materials are segregated by composition: cotton, wool, synthetic.
Expert eyes detect what machines cannot yet distinguish.
Color separation is crucial for the final fiber quality.
Hard contaminants like metal and plastic must be removed.
Sorted by color, the material needs no chemical dyeing.
Moisture levels are checked to prevent processing issues.
Large garments are reduced to uniform scraps.
Uniform pieces ensure consistent breakdown in the next stage.
The material now enters the fiber opening line. Spiked lattices begin to tease apart the woven structures. Lubricants reduce friction and heat during the tearing process.
Precise feed rates prevent machine jams and fiber damage.
Coarse teeth deliver the first heavy impact.
Magnetic traps capture any remaining metal fragments.
Powerful vacuums remove dust and microparticles instantly.
Keeping the fiber clean is essential for industrial strength.
The fabric structure is broken, but not yet fully fiberized. Thousands of sharp points must be kept in perfect condition.
Safety checks complete, the main processing begins.
High-speed cylinders generate immense centrifugal force.
The fabric is literally torn apart, thread by thread. The result is shoddy, a fluffy, fibrous material. Air currents transport the lightweight fiber to blending silos. Here, fibers rest and homogenize before the final breakdown.
Here, fibers rest and homogenize before the final breakdown.
Tons of material are accumulated to ensure consistency.
Blend is extracted evenly from the bottom.
Operators check for neps, tiny knots that need more processing.
A second, finer opening stage perfects the fiber separation.
Now, the heart of the process, the carding engine.
The chute feed ensures a perfectly even layer of material.
The liquor-in roller combs the tufts into individual fibers.
Millions of wire points align the fibers parallel to each other.
Revolving flats strip away short fibers and dust.
chaos becomes order. A delicate web is formed.
The doffer carefully peels the web from the main cylinder.
Oscillating combs vibrate to detach the fragile web.
It is lighter than air, yet strong in unity.
The wide web is condensed into a continuous rope called sliver. Coiled into cans, the sliver is ready for the next step.
Automation bridges the gap between processing stages.
Multiple slivers are combined to build density and strength.
The crosslapper layers the web to create a thick bat. Layer upon layer, the material gains volume and insulation properties. Entering the needle loom, the loose fibers will be locked together. Thousands of barbed needles mechanically interlock the fibers.
This mechanical bonding creates a strong, durable felt without glue.
Multiple passes increase density and surface finish.
Broken needles must be replaced immediately to ensure uniformity.
Heat activates low-melt fibers, locking the structure permanently. Microscopic fusion points create a resilient industrial material.
Emerging from the heat, the felt is stabilized and sterilized.
Heavy rollers compress the material to precise thickness specifications. Density is key for acoustic and thermal insulation applications. Rapid cooling sets the dimensions permanently.
Laser scanners ensure every millimeter meets industrial standards.
The accumulator buffers the continuous flow during roll changes. Edges are trimmed for a perfect, uniform width. Even the trimmings are recycled back into the system. Finally, the continuous sheet is wound into massive industrial rolls. Proper tension prevents telescoping and ensures stability. Automated cutters sever the sheet at the exact length required. A finished roll can weigh over 500 pounds. Production continues 24/7 to meet global demand. Heavy lifting is handled entirely by robotics. Protection is the first step of quality control.
Shrink wrap seals the product against moisture and dust.
Ends are sealed to create a watertight package. Every roll carries the certification of its sustainable origin.
In the lab, samples undergo rigorous physical testing.
Tensile strength is tested to ensure durability under stress.
it must withstand forces far beyond its intended use.
Fire resistance is critical for automotive and building insulation.
Acoustic properties are verified for noise reduction applications.
A final metal check guarantees the product is 100% safe. Roll dimensions are verified against the shipping manifest. Upended rolls are prepared for palletization.
Robotic stacking maximizes shipping efficiency and stability. Robotic stacking maximizes shipping efficiency and stability.
The entire pallet is secured for long-distance transport.
Forklifts move the finished stock to the distribution bay.
This facility stores thousands of tons of recycled potential.
Inventory is managed digitally for precise tracking. Orders are dispatched to automotive and construction industries.
Old trucks depart daily, closing the loop on waste.
Secured and ready, the material begins its second life. Transportation efficiency is also part of the sustainability equation.
The process is designed to be as clean as the output.
From discarded rags to premium industrial felt,